So radical equations. Do extraneous solutions show up on graphs? So just a reminder what extraneous solution is. Extraneous solution is a solution that we can find algebraically that doesn't actually exist. It doesn't actually work when you plug it back into the equation. So do extraneous solutions show up on graphs? And the answer would be no. Okay. Extraneous solutions do not show up on graphs. So if you graph the original equation, you will not see an intersection of points, or if you graph it equal to 0, you will not see the graph cross 0. Okay, so extraneous solutions never show up on graphs. So what that means is we can actually check for extraneous solutions on graphs as well. So if we only see one solution on a graph, and we get two solutions algebraically, that means that one of those solutions must be extraneous. So why is there no real solution to this particular equation? So we have the square root equaling -2. Well, we can explain this by the fact that the principal square root is always positive. Okay, so the principal square root is always positive. Okay, so that means that it cannot equal -2. Therefore, not equal to -2. It's not possible. So if I were to graph this then, where would the extraneous solution of this graph show up? Okay, so we should start getting an idea what these radical equations look like. Okay, so I'm going to graph square root 2x minus 1, and I'll also graph -2. Okay, so when we graph this, what does this graph look like? Okay, so if we graph y equals -2, that's going to be pretty straightforward. Y equals -2 is going to be this line, horizontal line at y equals -2. Okay, so when we graph this, the square root equation, remember that this is the domain of this equation. Okay, if we think of the domain, it must start at positive 1/2, and we must have the domain as positive. Okay, so we must have only positive values in the square root. So it's going to go to the right. So we're going to start at 1/2. Okay, so that's going to be x equals 1/2. Write that a little bit. Equals 1/2. Okay, and it's going to be a half parabola that looks like that. Okay, so where would the extraneous solution show up in this graph? Okay, so notice that there's no solution to this. Okay, these two graphs do not intersect. So where could we find the extraneous solution on this graph? Well, the reason why we have an extraneous solution, and let's actually solve this. We have 2x minus 1 equals -2. Actually, I'll do that in color here. So we have 2x minus 1 equals -2. Okay, so there's no solution to that equation. Our algebraic solution requires us to undo the square root with a square. And I need to square both sides. And because the square and the square root are not perfect opposites, when we do that, we introduce the fact that this could have been the negative square root squared, and it would still equal +4. And so what ends up happening is we generate this other half of the parabola. Okay, so we have the square root represents the positive half of the parabola, and when we square it, we introduce the fact that this could have been the negative half of the parabola down here. And now we've introduced, from this point on, the possibility that we could find this extraneous solution. So when we solve this, we get the extraneous solution x equals 5/2. Okay, and this is extraneous. Okay, it doesn't work when we plug it in. Okay, when we plug it in, we end up with, that would end up being square root of 4 equals -2, and that's not true. Okay, and there's our extraneous solution. Okay, at x equals 2.5. Okay, and this again, this is extraneous because it doesn't actually exist. This dotted line is not part of the original equation. So the extraneous solution of this shows up on the graph. It's the intersection of the bottom half of the parabola. Okay, and I'm going to just put in brackets here. This would be the negative 2x minus 1. It's the bottom half of the parabola with the line y equals negative 2. Okay, so if the bottom half of the parabola, which doesn't exist, intersects with the line y equals negative 2. So there is where the extraneous solution would be on the graph. We can actually visualize the extraneous solution here. Okay? And we should also make sure we're clear though. We have to be clear that there's no solution to this because the red and the green represent the original equation and there's no intersection between the red and green graphs.